So in this video today, we're going to be looking at the gamma function, and we're not going to go into a deep mathematical basis. It's some pretty complex maths. However, it's got some interesting results, and the main one to take away is that the gamma of z is, or any number, is the number before it factorial. And this is for extending the factorial function to beyond the natural numbers. So obviously we know what like 0 factorial is 1, 1 factorial is 1, 3 factorial is 6, i.e. it's 3 times 2 times 1 and so on. But how do we find factorial of, say, a half? Yeah, well, that doesn't make any sense, because how do we multiply it by the number before it and so on? So we've got this thing called the gamma function. And the gamma function is defined as follows. So it is the integral between infinity and 0 of t to the z minus 1 e to the minus t dt. And it's got a few restrictions, but we don't need to go into that. And we plug in a number. So let's say we plug in z, and this is going to give us z minus 1 factorial. So let's do a few examples. So gamma of 0, or we should do gamma of 1. That makes more sense. So gamma of 1 is going to give us 0 factorial, which happens to be the same as 1 factorial, but hey. So we plug it into the formula, the integral between infinity and 0, and z, t to the 1 minus 1 is 0, e to the minus t dt. So that's just the integral between infinity and 0, e to the minus t dt. And that is just going to be the limit as, say, well, we can just use t. T approaches infinity of, or no, we should use n. Let's use n. N approaches infinity of minus e to the minus t. So we integrate e to the minus t between n and 0. So if we look at the e to the negative t function, it's a pretty poor sketch, but it approaches 0 as t approaches infinity. So we get that we've got, as n approaches infinity, it's 0, and we have minus, then e minus to the 0 is just 1 by definition. So that's going to be minus 1. Minus 1, sorry. And we get that that's 1. So gamma of 1 equals 1. Interesting. So now let's go up a few factorials, or not factorials, a few numbers, and let's look at gamma of, let's go with 4, because that's going to give us what? 4 minus 1 factorial, 3 factorial. So we should be expecting 6 as our answer here. So let's look. So gamma of 4 is equal to the integral between infinity and 0 of t to the z minus 1. So 4 minus 1 is 3, e to the minus t dt. So there's going to be some integration by parts here. So we set it up. U is equal to t cubed, du will be 3t squared. dv is equal to e to the minus t. V is going to be the integral of that, so e minus e to the minus t. So it's uv v du. So we're going to have that is equal to minus e to the minus t cubed. Or actually, I'll write it differently. We'll say minus t cubed e to the minus t, evaluated between infinity and 0. And then plus, because we've got a minus sign on that v term, infinity and 0. And we'll bring that 3 out, t squared e to the minus t dt. And if we look at this, no matter what we have here, this is obviously going to be 0, as you might say, oh well, t cubed, infinity cubed, it's going to be a massive number, still just infinity, but that e term is going to go to 0, and then even though this is 1 when t is 0, t in there 0, so it's going to go to 0. So then we just end up with 3 infinity t squared e to the minus t dt. So we have to apply parts again. So we're going to go u is equal to t squared, du is 2t, dv is e to the minus t, v is equal to minus e to the minus t. So again, uv, v du, and it's going to be minus t squared e to the minus t, between infinity and 0, plus this time 3 times 2. You see how that happens to start looking like what we were trying to get before? Infinity and 0. And we're going to have then t e to the minus t dt. And so we're going to have that again, going to go to 0, get rid of it. So we're going to have 6 integral between infinity and 0 t e to the minus t dt. And parts one last time. U is equal to t, du is equal to 1, dv is equal to e to the minus t, v is equal to minus e to the minus t. So uv, v du, and we're going to have, so that's going to be minus t e to the minus t between infinity and 0, which again is just 0, plus the 6 times the integral between infinity, 0 of e to the minus t dt. Now, I'm going to be lazy, and from before, we know that that's just 1, gamma of 1. So that is just going to be 6 times 1, which is 6. So gamma of 4 equals 6, which is 3 factorial. So we can see then that this works for integers. So this is obviously a pretty interesting topic, and I'm going to come back to it in the next video.